Good morning everyone. So today's video, pagpapatuloy lang po natin yung video ko ng nakaraan which is solving problems on a three-dimensional space. So under moment and couple na po tayo, no? So nag-stop po tayo dun sa last video ko dun sa uh, example number 2 po, no? So today, mag-start po tayo ng solve dun sa problem number 3. Okay, so we have here problem number 3. Attention, T of a magnitude 10 kilonewton is applied to the cable attached to the top A of the rigid mast and secured to the ground at B. Determine the moment mz of T about the z-axis passing through the base O. Okay, so we have here, ito, yung problem dito, we have here tension force na 10 kilonewton acting at point A to point B. So we have here 10 kilonewton at ang pinapahanap po dun sa problem natin ay yung moment at z-axis. So itong force po na to is papamoment natin dito sa z-axis. Okay. So to solve it, pwede natin gamitin yung mahabang process or pwede rin yung maikling process. No? Okay, solve natin po na pareho para ma-familiarize or masanay kayo na sinosolve both, no? Yung mahabang process at saka yung may maikling process. Okay, so we have here T, which is equivalent kay 10 kilonewton. So kailangan lang ulit natin hanapin yung segment A to B and line AB para makakuha tayo ng T in terms of vector component. Then, i-multiply lang natin yung vector component into distance, no? Perpendicular RAO. So, solve natin. Solution number 3. Number 3. Okay, so we have here T AB is equivalent kay tension force multiplied by AB segment over line AB, which is equivalent kay T, which is yung 10 kilonewton natin. Then itong AB is yung coordinates. So we have here, kung makikita nyo dito, we have here 9, 12, and 15. So kung ano yung distance from x-axis, yun po yung I. Yung distance from z-axis, yun po yung K. At distance from y-axis, yun po yung J. So we have here, distance from x-axis, ito yung x-axis natin. So ito yun, 12i plus yung J po natin ay ito. So since galing siya sa taas papunta sa baba, so negative po yung value ng J natin. So negative 15J plus yung Z natin which is 9K all over square root ni 12 squared plus 15 squared plus 9 squared. Therefore, we have here TAB is equivalent kay 10 multiplied by 12 all over the square root ni 12 squared plus 15 squared plus 9 squared. So we have here 5.66 I minus, so palitan lang natin yan, 10 times negative 15 all over the square root is 12 squared plus 15 squared plus 9 squared. So we have here negative 7.07 J plus 10 times 19 times 9 all over the square root ni 12 squared plus 15 squared plus 9 squared. So we have here positive 4.24K. So the value of tension AB, yung tension natin ito na naka vector component is ito po, no? Then we have here moment MO is equivalent kay R. So yung distance natin para kay z-axis, so we have here ito, papunta dito. So, we have here ROA multiplied by TAB. Okay, so we have here MO and ROA natin ito. So, malamang OA. So, 15 lang po yung ano natin. So, ito ay 15J. So, we have here 15J multiplied by TAB, which is 5.66I minus 7.07J plus 4.24K. Okay. Therefore, makakakuha tayo ng moment which is equivalent kay. So, same process pa rin tayo. Yung I, 0. Wala kang I dito. Tapos yung I mo dito is 5.66. Then, J, 15. And J dito is negative 7.07. Then, K. Wala kang K para kay R. 0. So, we have here 4.24. Then, i-rewrite mo lang ulit. 0, 5.66, J, 15, negative 7.07, K, 0, and 4.24. Then, multiply lang to. So, ito, pag ganito, pag ganito, pag ganito. Tapos ito, at ito. Okay? So, lalabas po dyan, MO is equivalent kay 15 multiplied by 4.24. Ito po yun. Minus, ito po, negative 7.07 times 0, quantity I, plus, J naman po tayo, 0 times 5.66 minus 4.24 times 0, J, plus, yung K po natin is 0 times 7.07 negative. Tapos, negative, ito. So, we have here 5.66 times 15K. Okay. So, lalabas, MO natin is equivalent kay, pagsamahin nyo lang po, we have here 63.45 as 63.645 645I minus 84.9K. So, unit po niyan is kilonewton meter. So, ang pinapahanap po is moment at z-axis. So, we have here ito, moment kay x-axis natin. Ito, moment natin kay z-axis. So, therefore, mz is equivalent kay negative 84.9 kilonewton meter. So, ito po yung mz po natin. Okay. So, ito yung mahabang solusyon, no? So, kung gusto niyo ng mas maiking solusyon, kailangan mo lang i-component po itong force natin na to. So, we have here tension force 10 kilonewton. So, pwede natin sabihin yung component po niyan is ito yung itsura. So, we have here component at y-axis, pag ganyan, pababa. Then, we have here component at x-axis, pag ganito. And we have here component at z-axis na pag ganito. So, ito ay si Fz, si Fx, and si Fy. So, kung mag-moment po tayo sa pinapahanap po is z-axis, dito po sa axis na to. So, itong Fy natin is magpapass through sa z-axis. So, hindi na siya mag-moment. Then, si Fz po natin is parallel sa axis. So, hindi din po siya. So, zero moment po siya. Therefore, ang mag-moment na lang po is yung Fx times the perpendicular distance na 15. So, therefore, makakuha agad natin yung value ni mz. So, based dito sa figure na to, solve natin yung mz. So, mz, moment at z, kasi yun lang naman yung hinahanap dun sa problem natin. We have here the component of fx. Yung component niya is para makuha natin yung component, we have here yung force 10 times yung uh, coordinates ng fx. So, yung coordinates ng fx is passing through 12 meters siya. Ito, 12 meters. So, lalabas ay 12 meters tayo dito all over the total length na to, which is equivalent kay square root ni 12 squared plus 15 squared plus 9 squared na z multiplied by perpendicular distance. The perpendicular distance kapag itong fx natin is magmumoment kay z-axis. Pag ganun po yung galaw niya. Therefore, yung perpendicular distance niya is yung 15. So, we have here 15. Then, mz is, makakompute na natin ito. Okay, so lagay lang natin sa calculator. 10 multiplied by 12 all over the square root ni 12 squared plus 15 squared plus 9 squared multiplied by 15 na this perpendicular distance. So lalabas we have here 0.85 kilonewton meter. Okay. So, bakit negative yun dito? Dito ay positive. So, yung sign po niyan is nag-indicate lang po ng direction ng moment. So, kung dito, titingnan natin dito, yung moment niya is pa-clockwise. So, therefore, clockwise po yung moment natin dito. Okay? Ito po yung value ni mz. Okay, next problem po tayo. So, problem number 4, determine the magnitude and direction of the couple moment M. Couple M, which will replace the two given couples and still produce the same external effect on the block. Specify the two forces F and F applied in the two forces of the block parallel to the YZ plate, which may replace the four given forces. The 30 Newton force act parallel to the YZ plane. Plane po yan. So, ngayon, we have here couple force, which is ito, 25 Newton and 25, same magnitude, opposite in direction. So, couple moment po yan. Then, we have here 30 and 30 Newton dito. So, opposite direction, couple din po yan. So, based dun sa question sa problem, itong dalawang couple na to is gagawing isa na same lang po yung effect dun sa block natin. No? Okay. Solve natin. Dito lang tayo sa isang whiteboard. Okay, so we have here this figure. So to get the total moment, pagsamahin lang po natin yung total moment nito, no? So para pag sinolve natin, dun sa total moment, gagawin natin or kukunin natin yung isang force na ma-apply na same lang ang effect dyan sa based dun sa figure natin. So we have here solution. Kita mo ba? Okay. Solution. Number 4. So, we have here moment, couple. So, kukunin natin yung couple, moment at y and z axis para, kasi yun naman yung hinahanapan natin ng plane na plane. So, we have here moment at y, which is equivalent kay, so, yung y axis natin is ito, at ito yung x axis natin, then z axis natin is naka-vertical. So, we have here yung pagsamahin natin yung lahat ng moment sa y. So, ang moment sa y is itong force na vertical na to. At itong patas na to. So, we have here 30 times 60 all over 1,000 sine 60. degrees equals. So, itong naka-angle na force natin which is 30 Newton. So, since naka-angle siya, may dalawa siyang component. So, we have here yung ito, downward force and yung pagganitong force niya. So, we have here, meron din tayong pagganitong force. So, bale, ito at ito is isang moment yan. Ito at ito is another moment po yun. No? So, yun. We have here my. So, ang mag-moment lang sa y-axis. So, kapag tinake natin tong force na to at ito, yung vertical component nito, yun lang yung nag-moment dun sa y-axis natin. No? So, makakabuo tayo ng pagganitong galaw ng ito, vertical force. So, we have here 30 times 60 all over 1,000 para ma-convert na into meters yung mm natin, multiplied by sine 60 angle. We have here 1.59 kilonewton meter clockwise pala. Kasi yung galaw ay pa ganito. Balik pa yung drawing. Okay. Clockwise. Then, we have here moment at z-axis. Yung z-axis natin is ito at ito. Then ito at ito. So, kapag nag-moment po yan, we have here itong 25. Magiging ganun yung galaw niya. Ito is pag ganito yung galaw. Opposite. No? So, we have here m. Z is equivalent kay 30 ulit tayo times distance 60 over 1,000 cosine 60. Since clockwise yung moment ito, positive tayo. Then ito, counterclockwise, negative tayo. Minus counterclockwise which is 25 kilonewton multiplied by perpendicular yung distance nila which is equivalent kay 100. So, 100 kasi ito, 100 din to. 100 all over 1,000 equals. So, sub po natin. We have here 30 multiplied by 60 all over 1,000 times cosine 60 minus 25 times 100 all over 1,000. So, we have here negative 1.6. 1.6. Newton pala yung unit. Newton meter. So, ibig sabihin, counterclockwise po yung moment natin. So, we have here 1.6 Newton meter counterclockwise. Okay, so ngayon, pagsasamahin natin yung dalawang moment para maging isang buong moment siya na mag-a-act dun sa plane x and z, y and z natin na plane, no? So, ngayon, we have here moment x, y is equivalent kay square root ni moment yz pala to. Yz, moment yz is equivalent kay moment y squared plus moment z squared. Therefore, moment yz is equivalent kay square root ni my natin is equivalent kay 1.55 9 squared plus 1.6 squared. Therefore, my z is equivalent kay square root ni 1.55 9 squared plus 1.6 squared. So, we have here 2.23 4 Newton meter na mag-a-act dun sa plane yz natin. So, ngayon, pinapahanap is yung force na mag-a-act dun sa yz natin. No? Okay. So, we have here moment yz is equivalent kay force times yung distance. So, we have here moment yz which is equivalent kay 2.234 times yung force which is yung na hinahanap natin times yung d. Yung d is kung ito yung yz natin, ito yung z na axis tapos yung y natin na axis na to. So we have here this value which is 1 mm, 100 mm pa rin. So lalabas to ay 0.1 meter pa rin yung distance natin. Therefore, we have here f is equivalent kay 2.234 divide 0.1. We have here 22.34. So, Newton. So, yung force na i-applied natin is 22.34 Newton na lang, no? So, kumbaga, itong 30, 25, matatanggal yan. Tapos, papalitan na natin siya ng force na 22.34 Newton. Pero, syempre, may location pa rin po yung paglalagyan itong 22.34. So, to get the location or the angle, so, we need to solve tangent theta, which is equivalent kay my over mz. Therefore, arctan, my, the value of my is 1.559 all over 1.6. Therefore, theta is equivalent kay, itong theta na to ay theta yz to, equals 44.3 degrees. So, yung 44.3 degrees, yun po yung mag-act dun sa force natin na to, no? So, kung pag-apply natin ng force dun sa plane yz is force 22.34 with an angle of 44.3 degrees. So, the answer is itong myz na pinapahanap yan, tapos itong force at yung theta, no? Okay. Next problem po tayo. So, kung may mga tanong kayo, chat nyo na lang sa comment section, no, para at least masagot ko kapag hindi malinaw dun sa explanation with regards dun sa video na pre-represent ko. Okay, we have here example number 5. Burahin ko ulit yung problem. Okay, gamitin muna natin itong malinis na board na to. We have here problem number 5. A force of 40 pounds is applied at A to the handle of the control lever, which is attached to the fixed shaft OB. In determining the effect of the force on the shaft at a cross section such as that at O, we may replace the force by an equivalent force at O and a couple. Describe this couple as a vector M. So, ibig sabihin, itong force 40 kilonewton, 40 pounds po natin na to is ita-transfer natin dun sa point O na magkakaroon ng same effect, no? Kumbaga dito, is same effect pag transfer natin. In addition, may moment na ma-attach dito, no? So, yun yung pinapahanap dyan sa problem natin. Okay, we have here this figure. So, ang gagawin lang natin to get the force needed to apply is, syempre, ito transfer lang natin to, no? So, ibig sabihin, 40 pounds pa rin naman yung i-apply natin na force. Yun nga lang, yung 40 pounds natin is may kaakibat or may kasama na siya na moment, no? So kung nag-act siya ng 40 newton dyan, pag ganon, so we have here also 40 pounds pala. So, meron din tayong 40 pounds dito na mag-act. So, isa na ito sa sagot, no, na force na ma-apply. So, dun, no, determining the effect of the force on the shaft, no. So, ibig sabihin, yung force 40 is 40 pounds pa rin yung i-apply natin. Yun nga lang, may kaakibat na moment na to. May kasama na siyang moment. Ganyan yung magiging itsura. Okay? So, to get the value of moment, we have here solution number 5. Solution number 5. We have here, kung ito yung force, i-moment na siya natin dun sa point O. So, kung point O yan, i-moment natin siya dun sa axis ng O. So, meron tayong axis ng Z, Y, and x-axis, no? So, kung ito ay pag ganito, ibig sabihin, wala nang moment dun sa x. So, wala tayong mx, no? Kasi nga, parallel siya dun sa x-axis. Therefore, ang moment na natin ay moment sa z at moment sa y-axis. Okay, solve natin yung moment sa y-axis. We have here my is equivalent kay yung force sa y-axis natin pagagalawin. So, ito yung y-axis natin. So, ito is pag ganon. Tama ba? Kung ito yung axis natin, para siya makapunta sa point O na y-axis, tama bang ito pag ganito, ang galaw. So, therefore, we have here 40 pounds multiplied by perpendicular distance, which is 2 plus yung 3 na to. Ito. 2 plus 3. We have here 5 inches. So, we have here 200 pound inch. So, the direction will be clockwise. Then, we have here moment at z-axis. We have here 40 ulit. So, para maka-moment siya sa z-axis, ito yung z-axis natin. Ito, papapuntahin natin dito sa z. Tama ba ang galon tayo pag ganito? So, ito is matatransfer pag ganito. So, we have here 40 pounds multiplied by the perpendicular distance, which is 8, equals 320 pound inch. The direction will be counterclockwise. So, ngayon, para makuha natin yung moment, m is equivalent kay square root ni my squared plus mz squared, which is equivalent kay square root ni 200 squared plus 320 squared. Therefore, m is equivalent kay square root ni 200 squared plus 320 squared. We have here 377.359 pound inch, no? Then to get the angle nung syempre yung angle niyan is para makuha natin. So ito na isa na to sa sagot. So to get the angle, we have here tangent ulit. Tangent theta yz ulit equals my over mz, which is equivalent to kay 200 all over 320. Therefore, theta yz is equivalent kay arctan 200 over 320. We have here 32 degrees. Okay, so ito po yung answer. Okay, next problem po ulit tayo. So, yung mga problem po na to is pinagkukuha ko lang sa libro ni check ko lang kung libro to. Libro ni J.L. Miriam and L.G. Kriage. Engineering Mechanics Statics, 7th edition siya. Okay, next problem po tayo. Okay, so we have here the steel H-beam is being designed as a column to support the two vertical forces shown. Replace this force by a single equivalent force along the vertical line, center line of the column and a couple moment. Okay, so we have here this H o I-beam or H-beam na kung saan ay gagamitin as column daw. Then the applied load will be located here and here, which is 100 kips and 150 kips. Then ang sabi doon sa problem, ita-transfer daw itong dalawang load into single load. So dito daw siya mag-act sa center line na to. Plus yung moment na kasama, no? Ibig sabihin, ganito yung magiging itsura ng natin, load, no? So tatanggalin na natin yung 100 kips at saka 150 kips. Ito na yung magiging itsura niya. Pero ang question, ano daw yung magiging value ng F force dito at yung moment dito. Okay? Solution tayo. Dito na ako magsusulat. Solution. Number 6. So we have here, to get the value of f, pagsamahin nyo lang po yung total f na yan. No? So we have here f is equivalent kay 100 kips plus 150 kips. Therefore, we have here f is equivalent kay 250 kips. Ito po yung force. So, equivalent yan kay f is equivalent kay 25,000 pounds. 1 kip is equivalent kay 1,000 pounds. So, ito. So, ngayon, meron ka ng force dito. Ngayon, hanapin natin yung moment. So, to find the moment, we have here moment. M. So, kapag moment tayo, ang pinapahanap natin sa moment, we have here moment at y-axis and moment at x-axis. Kasi nga, since parallel siya sa z-axis, wala na tayo mag-moment sa z-axis. So, we have here moment at, unahin natin si x-axis. We have here moment at x-axis. So, kung sa x-axis ako mag-moment, ito yung axis natin ng x. So, therefore, yung 100 kips is nag-pass through dun sa 100, yung 100 kips natin is nag-pass through dun sa x-axis. Therefore, hindi na po siya mag-moment. Ngayon na, ang mag-moment is yung 150 kips. So, we have here 150 kips multiplied by the perpendicular distance, which is 3. Okay. So, para makita po natin kung ano yung moment niya, tama bang ito siya? Kung ito yung papaputayin ko dito, tama bang ganito yung galaw niya? Okay. Pero ito, kung nandito ako sa center, tama bang ang pagtingin ko dyan ay opposite nito, kabaliktaran? Kasi kumbaga ito yung clockwise to, pero kung dito ako, counterclockwise po ang makikita ako. So ito ay lalabas dyan ay counterclockwise po yung sagot dyan. We have here mx, which is equivalent kay 150 times 3, we have here 450 kips. No? Ang galaw po niyan is counterclockwise. Okay. Then, we have here m, y. So, magmumuhin tayo sa y-axis. So, kung dito ako, papunta to, tama ba ang galaw kayo pag ganito? So, we have here 100 times 6. So, kapag gumalaw siya pag ganyan, counterclockwise siya. So, negative po yung value nun. Plus, kung dito po ako tapos papuntahin ko ito dun sa center line, tama ba ang galaw ko ay pag ganito? Clockwise. So, ibig sabihin positive po siya. So, lalabas plus 150 times perpendicular distance, which is 6. Therefore, my is equivalent kay, my po natin is negative 100 times 6 plus 150 times 6. We have here 300 kips. Inch pa pala. Ito pala ay may inch. Tapos, counterclockwise. Ito ay, galaw niya is clockwise. Therefore, ito ay positive, ito ay negative. So, kung susulat natin yung moment, we have here, moment is equivalent kay 450 I, negative kasi nga counterclockwise, plus 300 y, j siya. So, lalabas, ito po yung sagot natin, kips inch. Or either, ito kasi, yung sagot natin is naka-vector quantity, vector component pa siya. No? Yung identify mo pa kung ano yung sa I and sa y. So, pwede naman natin siyang i-solve into moment, which is equivalent kay square root ni 450 squared plus 300 squared. So, we have here 540 na moment, 0.832 kips inch. Okay. So, ito po yung actual moment na ilalagay natin dito. No? Kung sakaling yun yung hinihingi. Pero kung ang pinapahanap is component ng moment, ito po yung vector component niya. No? Okay. So, yung mga video na pinapanood nyo pa lang is lecture 1 and lecture 2 pa lang to, no? So, kumbaga ay parang ito pa lang yung mga concepts. Kumbaga, tinuturo ko pa lang kung ano yung mga concepts ng pag-solve ng components, ng pag-moment, pagkuha ng resultant, no? Kasi pagdating natin sa equilibrium tsaka sa mga structures na medyo mabilis na lang 'yon. Tsaka kung naintindihan niyo yung pagkuha ng moment, pagkuha ng resultant, pagkuha ng mga components dito sa video na lecture 1 and lecture 2 ko, ibig sabihin mas mamaniin niyo na lang yung mga susunod na topic, di ba? Okay. So we have here problem number 7. Two forces acting on the handle of the pipe wrench constitute a couple M. Express the couple as a vector. Okay. So, itong couple daw na to is kukunin lang natin siya as a vector, no? So, gagawin lang natin is individually, i-moment natin siya sa axis para makakuha tayo ng vector component. Okay. So, kung ito ay y-axis natin, ito yung x-axis natin, malamang yung z-axis natin is vertical. So, wala tayong z-axis kasi nga vertical po yung loads natin, parallel siya, no? So, we have here solution. Solve na lang natin. Solution number 7. We have here, moment muna tayo sa x-axis. Mx is equivalent kay, kung x-axis is ito, so kung ito, pag ganon, we have here 150 multiplied by 250 all over 1,000 para maging meters. Clockwise, positive. Then, ito ay clockwise pa rin, positive, plus 150 times perpendicular distance, which is 250 then all over 1,000. Therefore, we have here 150 times 250 over 1,000 times 2. We have here 75 Newton meter. Then, for moment at y-axis, sa y-axis tayo mag-moment, ito ay wala ng moment kasi nga nag-pass through siya sa y-axis natin. Ito yung y-axis natin. So, ito na lang gagalaw. So, we have here, pag ganun ang galaw niya, clockwise pa rin siya. So, positive yung value natin. So, we have here 150 multiplied by the perpendicular distance, which is 150 all over 1,000. We have here 150 times 150 divide 1,000. 22.5 Newton meter. Okay. So, kung makikita ninyo, yung sa MX natin, kung dito ako nakatingin, sa pag ganito yung tingin ko, tama bang clockwise yan? Pero kung dito ako nakatingin, sa point na yan, sa point O, sabihin kong point O yan, tama bang kabaliktaran yung makikita ko? Kaya magiging counterclockwise yun. So, therefore, magiging negative values po to, no? So, yun. Then ito, kung dito ako nakatingin, clockwise pa rin po itong nandito. So, lalabas, ang value ng M natin dito is M is equivalent kay negative 75 I plus 22.5 J Newton meter. Okay. So, sa mga problem kasi na 3D, mahirap ma-identify agad kung ang moment ba is naka-clockwise or naka-counterclockwise yan, no? So, depende yan sa kung saan nakatingin or kung saan siya mag-moment. Kung halimbawa, dun ka sa point O, dito ka sa point O na to, so, ibig sabihin, kung paano mo siya tingnan, galing dun ka sa point O. So, ang galaw nito is pag ganon at pag ganon. So, ibig sabihin, pag tinignan mo siya, gumanito ka, dito ka galing, makikita mo, counterclockwise siya. So, negative siya, no? Pero kung dito ako galing, kung baga nakatingin kayo ng as is nakatingin kung ano nakikita niyo dyan, ang galaw niyan is clockwise, tama? Pero kung doon ako galing, counterclockwise po yung mangyayari. No? Same din po dito. Clockwise to ang movement nito. No? Kasi away from O tayo is clockwise positive. Okay. Next problem tayo, problem number 8. Okay, so si problem number 8 is parang yung na-solve na natin siya nung nakaraan, pero ang pinapahanap lang yun is value ng component ata, no? Component lang nung nung t. So ngayon is isi-solve natin siya as kukunin natin yung mga moments, no? Maambon na siya. Okay, so we have here the rigid pole at the cross arm assembly as shown. Determine the vector expression for the moment of the 1.2 kilonewton tension about point O and about the pole Z axis from each moment in the two different ways. So yung two different ways, hindi na natin siya gagawin, no? Isang beses lang natin siya i-solve, no? Para hindi tayo masyadong mahirapan. Okay, solve natin. So we have here this figure. So solution ulit tayo. Number 8. So we have here force tension 1.2. So to get the value of t, di ba na sundan na naman natin siya kung paano kunin. So we have here t CD is equivalent kay 1.2, diretso na natin, multiplied by the coordinates. Ang coordinates niya is 1.5 I. So ito yung I natin, 1.5 I. Ito, 1.5 I. Plus, yung y-axis natin ito, plus 3j minus yung distance na to, which is 4.5. We have here negative 4.5k all over the square root ni 1.5 squared plus 3 squared plus 4.5 squared. Okay, we have here t, c, d is equivalent kay solve na lang natin diretso. So we have here 1.2 multiplied by 1.5 all over the square root ni 1.5 squared plus 3 squared plus 4.5 squared. So we have here 0.32 I, 21 I plus 3, 1.2 times 3 all over the square root ni 1.5 squared plus 3 squared plus 4.5 squared. We have here 0.641 j minus 1.2 multiplied by negative 4.5 all over the square root of 1.5 squared plus 3 squared plus 4.5 squared. We have here 0.96k. 962k. Okay, so we have here moment is equivalent kay ang imo-moment ko po ay ito yung gagawin, ita-transfer ko po itong force dito, no? We have here 1.2. Para ang distance ko na lang na gagamitin ay itong nandito, no? Last time, ang ginamit natin na distance ay ito, di ba? Doon sa solving natin. From this point to this point. So ngayon, ang gagamitin ko ngayon is ito, papunta dito. So we have here ROD multiplied by TCD. So si ROD is equivalent kay 3J multiplied by TCD, which is 0.321I plus 0.641J minus 0.962K. Okay? So, di ba, parang nag-interchange lang siya nung nakarang natin. So, we have here, isusulat ko lang ulit siya. I. Walang I dito. 0 ulit tayo. Then, I dito is 0.321 1I, then J which is 3 dito, sa side na to, tapos 0.64, tapos K, 0 ulit tayo, then negative 0.962. Then, as is pa rin tayo, I, J, and K. No? Then, lalabas, hindi ko na isusulat ha, lahat. So, ang lalabas dyan, we have your moment dito, is equivalent kay, moment is equivalent kay negative 2.89 I minus 0.963 K. Kilonewton meter. So, isusulat ka na lang dito. Moment is equivalent kay negative 2.89 I minus 0.962 K. In kilonewton meter. So, yan po yung moment about point O na naka-vector expression pa siya. No? So, ngayon, pinapahanap din po is yung moment about ito. Moment about z-axis. So, pinapahanap yung moment about z-axis. So, ang z-axis na rin is ito. So, mz is equivalent kay negative 0.962 kilonewton meter. So, diretso agad ang sagot, no? Or either, sabi naman dyan, solve in two different ways. I-solve natin ng MSA na i-component po natin yung value, no? Okay. Solve ko na lang dito sa baba. So, let's say na yung force natin na to is i-component ko. We have here, ito yung 1.2 na force natin. Bang meron akong force z-axis na to. Meron akong along y-axis at meron akong along x-axis. So, kung pinapahanap is z-axis, moment sa z-axis, bang itong mz fz natin ay hindi na siya mag-moment kasi nga parallel siya, no? Then, kung ito ita-transfer ko dito, principle of transmissibility, tama ba? Principle of transmissibility, ita-transfer ko siya dito. So, we have your component na ganito, pababa, at pag ganito. Ngayon, si force na to, yung Fz nga natin is hindi na siya mag-moment kasi nga zero moment kapag parallel. Itong Fy naman natin is magpapass through dun sa point O na which is dadaan sa z-axis ito, z-axis. So, hindi na rin siya mag-moment, no? So, ngayon, ang mag-moment pa is ito, Fx natin, no? Okay, try natin i-solve. Kung pareho ang lalabas na 0.962. Okay, we have here Mz is equivalent kay Fx times yung perpendicular distance which is 3 meters. Okay? Okay, ano ang Fx? Mz is equivalent kay Fx. Yung Fx is yung force which is 1.2 multiplied by yung coordinates. Yung coordinates na x is equivalent kay 1.5. Tama bang sa x is 1.5 yung distance niya? So, lalabas tayo 1.5 all over yung total distance which is square root ni 1.5 squared plus 3 squared plus 4.5 squared. Therefore, we have here times multiplied by perpendicular distance which is 3. Moment z is equivalent kay, multiply natin, 1.2 times 1.5 times 3 all over square root ni 1.5 squared plus 3 squared plus 4.5 squared. We have here 0.962 kilonewton meter. Okay. So, yun. We have here Mz, which is 0.962 kilonewton meter. Okay. Yung negative ulit is the direction or yung kung yun ay clockwise or counterclockwise, no? So kung ito papunta dun sa x-axis natin, habang ang ikot yan is pag ganito, we have here clockwise, no? Pero kung dun ako sa point O titingin sa ilalim, mag-interchange siya, no? So lalabas, pareho lang po yun ng ano, no? Pareho lang po siya. Kumbaga, yung negative sign or yung positive sign naman dyan is nagre-represent lang naman siya ng direction ng moment, no? So kung kukunin naman natin yung buong moment na yan, yung negative sign is neglected naman siya, di ba? Kasi kapag nag-square root tayo ng mx plus my squared plus mz squared, negative man siya kung na-squared naman natin siya. So wala namang magbabago dun sa actual moment, di ba? So yung negative is the direction lang po siya kung yun ay naka-clockwise or naka-counterclockwise. Sa book na kinukuhaan ko ng sagot, negative po yung sagot. Ibig sabihin counterclockwise po yung pag-ikot ng moment ay ng force, no? Okay, next problem tayo. Problem number 9. Check ko lang kung meron akong problem figure niyan. Wala ata akong printed figure. Okay, drawing na lang natin para so we have here axis. Siya nagsusulat. We have here x-axis, y-axis, and z-axis ito. So we have here perpendicular distance. So mag-act siya. Gagawin ko na lang na block yung ano. So we have here this one, this one, and so we have here this distance which is 250 mm and this one which is 200 mm. Isipin nyo na lang na mas mahaba ito kumpara dito. Tapos we have here force which is equivalent kay 1,200 Newton with an angle of 60 degrees here and moment which is 240 Newton meter. Okay. So, yan po yung nasa drawing natin, no? Kumbaga ito naka-free body diagram na siya. So, makikita mo na lang is yung mga forces, axis, and tsaka yung distance, perpendicular distance. Okay, solve natin para mas makuha natin yung sagot. Okay, solution number 9. So, the special purpose milling cutter is subjected to a force of 1,200 Newton and a couple of 240 Newton meter as shown. Determine the moment of this system about point O. So, yung point O natin is itong nandito. Then, ito, we have here force which is 1,200 Newton and couple moment of 240. So, ito si point O. So, ito is i-moment lang po natin doon, no? So, pinapahanap daw yung moment doon sa system natin at point O. So, lahat ng forces or lahat ng moment is papupuntahin natin sa point O, no? Okay. So, ngayon, umpisan ko muna dyan sa 1,200 Newton, no? So, kung magmo-moment ako sa point O, tama bang iko-component ko ito as pag ganito at pag ganito. So, wala akong, kumbaga ito ay walang component na along x-axis. No? Walang fx. So, meron lang ako dito fz and fy. Kasi nga, walang distance yung x natin. No? So, ngayon, para makuha natin yung sagot, we have here m ng 1,200 at point dun sa O. We have here distance natin. R, dire-diretso agad tayo R, sabihin kong point A. A ito. So, ROA multiplied by yung force, which is F na lang muna. Equals na. Equals. Okay, so we have here moment 1,200 is equivalent kay is equal to ROA natin ay ito, distance na to at itong distance na to. So we have here 200, sabihin kong point 2 I kasi 200 mm to, mm pala to. 200 mm along x-axis, so I po to, 0.2i plus, ito ay z, so ibig sabihin 0.25k. Okay, we have here 0.2i plus 0.25k multiplied by, so ito ay fz. So pag fz, k po siya. Fy, ibig sabihin j po tayo. So we have here 1,200 sine, kung sine po tayo 60, ibig sabihin fy po yung kinuha natin, therefore yan po ay j plus 1,200 cosine 60 then k. Okay? Ngayon, pagsasamahin natin siya, therefore lalabas yan ay m 1,200 is equivalent kay 0.2i plus 0.25k. 200 sine 60 is equivalent kay 1,200 sine 60 equals 1,036 39. 1,039.23 j plus 1,200 cosine 60. We have here plus 600k. Ano ka siya? 600k. Yan. Ngayon, gagamitin ulit natin yung ano. We have here I, which is equivalent kay 0.2. Then, wala kang I dito, so 0. Then, J, wala kang J dito, 0. Then, yung J dito is 1,039.23. Then, si K, may K ako dito, 0.25. Then, meron akong K which is 600. Then, sulat ulit yung si I, J, and K, no? Okay, so since kabisado nyo na rin yan, cross multiply lang, ano lang pag ganyan, at pag ganon, pag ganon, pag ganon. So, lalabas po doon sa equation natin, we have M, 1,200 is equivalent kay negative 259.81i plus 120 j plus 207.85 k. So, ito po is vector component ng moment ng 1,200 pa lang po, no? So, ngayon, yung moment naman po na ito, ng 240, yun naman po yung gagawin natin. Di ba may binigay akong formula sa inyo na M prime is equivalent kay RM dun sa discussion natin. So, itong M prime is equivalent kay RM is magagamit po natin ngayon kasi nga, itong moment 240 is ita-transfer natin dun sa point O, no? So, meron tayong component din nito. So, lalabas yan. We have here M prime is equivalent kay, yung M natin is 240, tama? Then yung R natin is, ito pa rin yung R natin. So lalabas we have here, hindi pala ito yung R natin. So lalabas we have here, yung sine at saka cosine niya. So we have here J sine 60 minus K sine 60. Negative po pala ng 600 natin. Negative. Negative din to. No? Kasi the direction of F Z natin is counterclockwise siya. No? Ngayon, 240 times J sine 60 minus K sine 60. We have here M is equivalent kay 240 J sine 60 minus 240 K sine 60. Then, pagsasamahin mo po yung may J at yung may K. So, itong J dito, pag hanapin mo yung may J, itong 120 plus nito, tapos ito at ito. So, lalabas, MO natin is equivalent kay, pagsasamahin natin, so we have here negative 259.81i. Kasi nga, walang I dito. So, wala tayong ipa-plus. So, ito lang siya. As is. I-write lang natin siya dito. Plus, yung 120J plus nitong 240. So, isusulat lang natin yan. 120 plus 240 sine 60. Equivalent yan kay 327. 327.85J. Then, yung 207 minus nito, so we have here 207.85 minus 240 cosine 60. We have here 87 point, positive 87.85K. Therefore, the moment of the force 1,200 Newton and the couple moment of 240 Newton meter is equivalent kay negative 259.81i po ito plus 327.85J plus 87.85K. So ito po yung magiging moment dun sa O, no? Equivalent couple moment, equivalent moment nitong nandito, no? Okay. So again, nag-abot na naman tayo ng 1 hour, no? Medyo boring na tingnan kapag sobra na yung oras, no? So next video natin is ipipresent ko sa inyo yung topic natin, which is resultant naman po tayo, no? So sa video na na-upload ko na, we discussed na yung forces, scalar vector, no? Under forces, we have here two-dimensional force and three-dimensional force system. So dun sa two-dimensional force system, pinag-usapan natin dun yung pagkuha ng component, pagkuha ng moment, pag-identify ng couple, at pagkuha ng resultant. Then, dun sa three-dimensional force system, na-discuss ko na din sa inyo yung pagkuha ng component. Then, ito nga, yung moment. Then, sa next video ko is the resultant. Then, yung mga susunod na topic, which is equilibrium, is lahat po yun ay may kinalaman dun sa discuss ko na lecture 1 and lecture 2. So, kumbaga si lecture 3, which is equilibrium, is the application na nung lecture 1 and lecture 2, no? So, kumbaga, dun sa lecture 3, hindi na rin naman natin identify yung mga I, J, and K na yan, no? Hindi na rin natin i-ano yan. Pero syempre, yung concept of getting the component, no? Dapat ma-identify nyo na, or marunong na kayo, or kumbaga, kabisado nyo na, no? So, I do hope na itong video presentation ko is nakakatulong sa inyo, no? Para ma-boost naman yung kasi ngayon, pandemic, ang hirap makagain ng knowledge, no? Kasi hindi naman nagkakaroon ng face-to-face classes. So, I do hope na itong video na piniprepare ko is makatulong dun sa mga nag-aaral ng engineering, no? So, again, keep safe ulit tayo. Wear face mask and face shield kapag lalabas, at magbaon tayo ng alcohol, no? Kung sakali, para lagi tayong safe.